Number 1, for each term provided, state two more like terms. So question A, 3x cubed. So we just need to find two more terms that have the same variable base and the same exponent. So it doesn't matter if the coefficients are different. So for example, this first one, x cubed, same variable, same exponent, different coefficient. 2x cubed is also a like term. It's got the same variable base, x, and the same exponent, cubed, but the coefficient is different. Question B, negative 2x. So as long as the variable is the same, it doesn't matter what the coefficients are. So x would be a like term, or 3x would also be a like term. (4a plus 2a). So we want to simplify that. They're both like terms, so we can add them together, giving us 6a. The next question, 5x squared minus 2x plus 4x squared minus 3x. We can collect the like terms. 5x squared and 4x squared are like terms. Negative 2x and negative 3x are like terms. Simplify. We can start by just putting them together next to each other so it's easier to see that they are like terms. 9x squared minus 5x is the final answer. Next question, 5x squared minus 2x plus 4 minus 3x squared. In this case, only two terms are like. We put them together so it's easier to read them or see that they are like terms. And then the 5x squared minus 3x squared becomes 2x squared, and the other two terms stay the same. In the next question, 5x squared minus 12x squared, they're both like terms. So we can complete them just like this. Next question, 6x squared plus 4x squared minus 5x squared plus 9x. We have two pairs of like terms. The 6x squared and then negative 5x squared are like terms. The 4x and the 9x are like terms. And that simplifies to x squared plus 13x. In the next question, 4g plus 6g minus 3 plus 2g. Three of those terms are like, so we can add or subtract them together. And the negative 3 is by itself for a final answer of 12g minus 3. Question 3a, 2x squared minus 2. So we'll expand them. 2 times x is 2x. 2 times negative 2 is negative 4. There's our final answer. Question B, once again, we'll expand. 3 times 2x squared is 6x squared. 3 times negative x is negative 3. Negative 1 times 5x squared is negative 5x squared. And negative 1 times negative 6x is plus 6x. Put our like terms together for a final answer of x squared plus 3x. Question C, we'll expand. 5 times y is 5y. 5 times negative 1 is negative 5. 4 times 2y is 8y. 4 times 3 is 12. Collect our like terms for a final answer of 13y plus 7. Question D, expand. 3 times 2x is 6x. 3 times negative 4 is negative 12. And there's our final answer. Question 4 asks us to solve for a variable. 3x equals 24. Therefore, x by itself is 24 divided by 3. Once again, this pattern, 3 times x equals 24. Then we take that 3 and divide it by 24, and that gives us what the x value is by itself, which resolves to 8. Question B, 4x equals 22. That 4 can just slide under the 22 like that. We'll do it one more time. 4x equals 24. Therefore, x by itself equals 22 divided by 4 for a final answer of 5.5. Question C, k minus 4 equals 13. If we slide that negative 4 over to the other side, it becomes a positive 4, and then we can solve it as such. K equals 17. dy plus 2 equals 11. We'll take that positive 2, slide it over to the other side. It becomes a negative 2. Y equals 11 minus 2. Y equals 9. Question E, x over 4 equals 5. Now, we have a 4 in the denominator. We'll go back here. We want to get rid of that 4 in the denominator. We can do that by multiplying the whole left side by 4. If we do that, then we have to multiply the right side by 4 as well to keep it balanced. On the left side, the 4's cancel out, and then we're left with x equals 5 times 4, x equals 20. Or we can approach this same question a slightly different way. X over 4 equals 5. The 5 could be expressed as 5 over 1. 5 and 5 over 1 are the same thing. And we do this because we're about to cross multiply. And if we have it set up like this, we can see the cross multiplication a little bit easier. So once again, x over 4 equals 5 can be expressed as 5 over 1. Now, cross multiplying, we want to keep the variable on the left-hand side, so we'll say 1 times x equals x. Cross multiplying the other way, 4 times 5 equals 20. And if you compare that, this question right here, answer right there, you'll see that it results in the same answer when we use the other method. So either way will work. T over 5 equals 30. T over 5 equals 30 over 1. We're simply expressing that 30 as a 30 over 1, at which point we can cross multiply. We want to keep the variable on the left-hand side, so we'll cross multiply this way. 1 times t equals t. 5 times 30 equals 150. Question G, 3 equals 2x plus 7. We want to get all our variables on the left-hand side and all our numbers without variables on the right-hand side. So we'll take that 2x, bring it over to the other side where it becomes a negative 2x. And we'll take the 3 that's on the left-hand side, bring it over to the right where it becomes a negative 3. So we get negative 2x equals 7 minus 3. Negative 2x equals 4. If negative 2 times x equals 4, then x by itself equals 4 divided by negative 2 for a final answer of negative 2. Two x minus 4 equals 18. Once again, we want to isolate the variable on the left-hand side and have the numbers on the right-hand side. So we'll take that negative 4 and we'll bring it over to the other side where it becomes a positive 4. 2x equals 18 plus 4. 2x equals 22. If 2 times x equals 22, then x by itself equals 22 divided by 2 for a final answer of 11. Now we're asked to check our answers for g and h. So g, the original equation, was 3 equals 2x plus 7. The solution that we got for x was negative 2. So now we're going to plug that negative 2 back into the original equation. We're going to substitute negative 2 any place that there was x in the original equation. And when we do that, we end up with 3 on the left-hand side and 3 on the right-hand side. So we can say the left side equals the right side. So we've just proven that negative 2 is indeed the right answer. Negative 2 as a value for x makes the original equation equal. And that's what an equation is. You can see it right in the word. In the word equation, we have the word equal. So 3 equals 2x plus 7. When x is negative 2, 3 equals 3, left side equals right side. For the other question, 2x minus 4 equals 18, the solution that we got was 11. So we take that 11 and we substitute it back into the original equation for x, we get 2 times 11 minus 4 equals 18. And when we finish that, we end up with 18 equals 18. Our left side equals our right side. Therefore, we can be really confident that we got the right answer, that x is indeed 11. Question 6a. 4w minus 4 equals 2w plus 6. Again, we want to get all of the variables on the left-hand side and all of the numbers on the right-hand side. So we'll bring that 2w over to the left-hand side where it becomes a negative 2w. Let's watch that again. So it's a positive 2w. We'll bring it over to the left where it becomes a negative 2w, and we'll take that negative 4 and bring it to the other side where it becomes a positive 4. Now we have our variables on the left and our numbers on the right. 4w minus 2w equals 2w, and 4 plus 6 equals 10. If 2 times w equals 10, then w by itself equals 10 divided by 2. W ends up being 5. Question B, r plus 2 over 3 equals negative 5. We could rewrite that negative 5 as a negative 5 over 1. Now we're set up so that we can nicely cross multiply. So 1 times r plus 2 equals r plus 2. 3 times negative 5 equals negative 15. So we'll take that positive 2 on the left-hand side, bring it over to the right-hand side where it becomes a negative 2. R by itself equals negative 15 minus 2. R equals negative 17. Question 3 asks us to expand. So 3 times x is 3x. 3 times 2 is plus 6 equals 4 times x is 4x. 4 times negative 5 is negative 20. Now we want the 3x and the 4x on the left-hand side, so we'll bring that 4x over where it becomes a negative 4x. And we'll take that positive 6, bring it over to the right side where it becomes a negative 6. 3x minus 4x is negative x. Negative 20 minus 6 is negative 26. If negative x, or negative 1x, equals negative 6, then x by itself equals negative 26 divided by negative 1, which is just 26. Question D. We can cross multiply. It's already set up nicely for us. 2 times q plus 3 equals 2 times q plus 3. Just write it down here. We'll keep it in the unexpanded form so far. 3 times q minus 5. Once again, we'll keep it in the unexpanded form. Now that we've got it down in this form, we'll expand it. 2 times q is 2q. 2 times 3 is 6. 3 times q is 3q. 3 times negative 5 is negative 15. We'll bring the q, all the q's or all the variables over to the left, so that 3q will become a negative 3q. And that 6 on the left-hand side will come over onto the right where it becomes a negative 6. And then when we simplify it, we end up with negative 1q, or negative q, equals negative 21. Q by itself becomes negative 21 divided by negative 1. Q equals 21. Now we're on to our word problems. Evelyn has 1 horse and 10 chickens. The equation C equals 8D plus 100 represents the total cost C to feed the animals for a certain number of days D. If Evelyn has $2,700, could she feed them for the entire year? Okay, so we'll write our equation down one more time. C cost equals 8 times the number of days plus 100. The cost of feeding the animals for an entire year would be expressed as C equals 8 times 365. So that's one of the challenges of word problems, is understanding that if we're talking about an entire year, then D has to be 365. So we plug that 365 into where D is in the equation. 8 times 365 plus 100 ends up being 3,020. Now the question asked, if she had $2,700, could she feed them for the entire year? Well, the entire year costs $3,020. So the answer to that question would be no, she would not have enough money. Use the formula D equals S times T to determine Dakota's speed in kilometers per hour if he runs 10 kilometers in 0.95 hours. So d is the distance, s is the speed, t is the time. Now we're given the distance, 10 kilometers. We're asked for the speed, we don't know it. And we're given the time, 0.95 hours. So we take these values and we plug them into the equation. 10 equals 0.95 s. We like to keep our variables on the left-hand side, so in this situation we could just easily flip them over. So we can say 0.95 s equals 10. If 0.95 times s equals 10, then s by itself equals 10 divided by 0.95. And that resolves into 10.53. So the answer to our question is Dakota's speed is 10.53 kilometers per hour. Question 11. One measure of a baseball pitcher's performance is WHIP, walks and hits per inning pitched. This statistic relates the number of runners who get on base per inning, R to the total number of walks, W the total number of hits, H, and the total number of innings pitched, I, according to the formula R equals W plus H over I. So we're told that the number of walks is 18, the number of hits is 35, and the total innings is 40. So we know W, we know H, and we know I. So we can just plug those values into the equation. Here's our equation restated again. We need to find out what R is. Plugging those values into the equation, we end up with 18 plus 35 over 40. R is 53 over 40. R equals 1.325. So our closing statement, Jesse's WHIP is 1.325.